All right, so for worksheet 2 in unit 1, we've got some questions about speed and velocity. And so in the first one, we've got a semi-truck driver who starts work in Milwaukee, making Milwaukee their initial position. And then they go up to Sheboygan. And then after Sheboygan, they go back down to Port Washington. And so here, we're going to have some interesting things happen because they change direction. Originally, they go north, and then they go south. It tells us that the first part of their trip took 1 hour and the second part took 30 minutes. So the final position is Port Washington. We can also call that mile marker 100. Their final distance is a little bit more complex. It's their first part of their trip, which was 47 miles, and the second part, which was 26. And it doesn't matter that second part is south, because when we're talking about distance, we look at the absolute value. And so no matter the direction, we add those together to get a total of 73 miles traveled, some of those miles north and some of them south. Their displacement, however, only depends on Port Washington and Milwaukee. And so we look at the difference in those positions and we get that they ended up 21 miles north of where they started. And that's why it's a positive 21 miles, because they end up at a position that's more north in Port Washington than they start in Milwaukee. How long did the whole trip take? Here we're just going to add the times from the problem, 1 hour and 30 minutes, to get a total of 1.5 hours. And then we're going to use the answers to part B and part D in order to find our speed. So we're going to take the distance of 73 miles divided by the time of 1.5 hours and get 48.7 miles per hour. Again, notice that there's no direction there because distance does not have a direction, it's not a vector. Then for part F, we're going to use the displacement in part C and the time in part D to find an average velocity of 14 miles per hour north. And notice that that does have the same direction for both the displacement and the velocity. For number 2, we've got Devontae Adams traveling to Chicago, and he leaves Green Bay at 8 a.m. and he gets to Port Washington at 9:30. He realized he forgot his cleats. And so then he backtracks to Manitowoc, and that's where he meets his wife to give him the cleats. So if you want to find the average speed, what do we need to find? And the answer is distance, because speed depends on distance. And so in order to find that distance, we have to take the absolute value of each trip. So this first trip is when he goes from Green Bay to Port Washington, which is south. And then the second part, so this is the south trip. And then the second part is from Port Washington back up to Manitowoc right there. But since we're talking about distance, we absolute value them and get a total of 129 miles traveled. Then for average speed, we just take that distance divided by the time, and this 2.5 hours depends on leaving at 8 and getting there at 10:30. So 2.5 hours is 10:30 minus 8. Then for part C, it asks us if we want to find average velocity, what do we need? And velocity depends on displacement. So we have to find the displacement only looking at the position of Manitowoc and Green Bay and disregarding the position of Port Washington. So there we see that he ends up 31 miles south of where he starts in Green Bay. And so then to find the velocity, we divide that 31 miles south by 2.5 hours, and we get an answer that is negative 12.5 miles per hour. Or another way we could write this would be 12.4 miles per hour. And then instead of negative, we could say south, because that's the direction that that negative sign communicates. Here we have some dairy deliveries, some ice cream deliveries near Abbotsford and Chippewa Falls. So this is actually the hardest question. The first part of number 3 is what is their total time? And to find that, we're actually going to use the speed limit on the highway, which we're going to assume that this delivery truck is following the speed limit. And then we're going to see, well, how much distance did they travel when they went from Owen to Abbotsford and then Abbotsford to Chippewa Falls. So when they went from here to here and there to there, what was their total distance? And if we use this speed and this distance, then we'll be able to calculate the time. So the distance we can find first. The distance is just each part of their trip. We'll take the absolute value of those parts and see that they traveled a total of 67 miles. And then here we'll use the speed equation, but we'll actually plug in 70 miles per hour for the speed, 67 for the distance, and we'll solve for time. So we're actually solving for the denominator of this equation, which is a little bit different than any of the other questions. And we see that if they were following the speed limit, it took them 0.96 hours in order to complete their 2 trips. The average speed, we're going to say is 70 miles per hour just based on the speed limit. And then for velocity, we have to find first the displacement because velocity depends on displacement. In order to find that, we'll find the difference in position between Owen and Chippewa Falls because that's where they started and ended. We see that they ended up 43 miles to the west, and then we can use that displacement and the time found in part A. So this displacement and this time, and we can find out that the velocity was 45 miles per hour to the west. And you can see that if we are diligent and we say that our displacement was negative, then our velocity is also negative. In English, that means that since our displacement was to the west, then our velocity is also to the west. And for the final question on this worksheet, we've got the same milk delivery truck. It's going from Wausau to Chippewa Falls and then from Chippewa Falls to Abbotsford. So to find the total time, this is similar to before. We need to see when they ended, which was at 9:45, and when they started, which was 8. And so between 9:45 and 8, there's 1 hour and 45 minutes, or 1.75 hours. Then we can use this time and the distance that they traveled in order to find the speed. So first we need to find that distance. The distance is the absolute value of each displacement in each part of their trip. So we can see that even though they traveled to the east to start with, which would be a negative direction, to the west. Even though they started traveling to the west, which would be a negative direction, that still becomes a positive 72 miles for distance. And so the total distance that they traveled was 127 miles for their 2 deliveries. If we then divide these 2 quantities using the speed equation, we get that distance divided by that time, or 72.6 miles per hour, which is slightly over the speed limit. Then to find the velocity, we need to find the displacement instead of the distance. So finding the displacement, we're only going to look at Wausau and Abbotsford and what the difference between those 2 positions are. Then we're going to divide that displacement by the time and find out that the velocity was 9.7 miles per hour to the west. Again, these directions and these negative signs are linked. They communicate the exact same information. Thank you for watching.